Hello, this video will be going over our first week, August 20th through 24th, Unit 0, the 8th grade review. What we covered this week was the real numbers diagram on Monday, on Tuesday, identities and inverse operations, Wednesday, distributive property, Thursday, the order of operations, and Friday we had our quiz. These are the topics. I'll be posting a link to this video here. Right now it just says WIP, that's work in progress. And here you can see a whole bunch of Khan Academy videos that will help with the various topics. So if you're having difficulty with a single topic, just go to those videos. If you're having it with multiple, maybe check out more of them. So here's classifying numbers, identity property of 0, identity property of 1, etc. One thing that we seemed to be really rusty on was the multiplying two fractions. So this one especially, some of you will want to check out. And then also some Khan Academy exercises. So you can check out the exercises if you're having trouble, maybe watch some of the videos or use the hints, or watch this video. So the real number diagram, this was basically where you've got kind of nested dolls things, and so you have your natural numbers, also called your counting numbers, and these are your 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Okay? It does not include zeros, does not include negatives, and it doesn't include anything between these numbers, so no 1.5, no 2.3. Okay. And then beyond that, so all natural numbers are also whole numbers, but not all whole numbers are natural numbers. In particular, 0. Okay. So all of the natural numbers are also whole, so 1, 2, 3, 4, 5, 6, 7, etc. They're natural and whole numbers. But then we also include 0 in the whole number set. So 0 would not belong in the natural number set, but it does belong in the whole number set. And beyond the whole numbers, we've got our integers. And these are going to be all of the whole numbers and their opposites. And the opposite of a number is the same numeral with the opposite sign. So in this case, all natural numbers are positives. So it would be 1 and -1, 2 and -2, 3 and -3, etc. But it also includes 0. So these are going to include your negatives. Okay. But not between those numbers. So no -2.5, no +2.5. Those we see when we get to the rational numbers. Rational numbers. And these are all of the numbers that can be thought of as a over b. Anything that can be written as a fraction. So 1 can be written as 1 over 1. 2 can be written as 2 over 2. So all the natural numbers are also rational. 0 can be written as 0 over anything. So that can be written as a fraction. -1 can be written as -1 over 1. Okay? So all of the integers are also rational. But then you'll have things like 5 over 7. Okay? This one is in between 1 and 2. So it's not an integer, but it is rational. Or you might have -33%. Or you might have 5.7. All of these can be written as a fraction. And then we've got a much larger set. And these are your real numbers. And separate from the rational numbers, you've got your irrational numbers. Irrational. I'm just going to put IRR apostrophe L. Irrational. And these are numbers like pi, phi, e, all the numbers that cannot be represented as a over b, okay, or some number over some other number. Okay. We can get close to these numbers. Several grades ago, you might have estimated pi as 22 over 7. Okay. Now that is rational, but it's not actually pi, it's just an estimation for it. Okay. And then I think towards the end of this year, or perhaps early in Algebra 2, we'll also learn about a set of numbers called imaginary numbers, and those are outside of the real numbers. So, all rational numbers are real, all irrational numbers are real, all integers are rational, all wholes are integers, and all naturals are wholes. So if you have 1, that's going to be natural, whole, integer, rational, and real. Okay? But then if you have something like 5/7, that's just going to be rational and real only. Okay. We also have a note sheet that we took on that, and I'll be posting the pictures in case you did not get them yourself. The next topic is identities and inverses. As I told you in class, I'm not going to be too worried about you memorizing the terms, but you do need to memorize the processes, what's going on with these. So the additive identity, this is where if you take a number a and you add 0 to it, you just wind up with a. Okay, adding 0 to anything does not change it. And then inverse, if you have a number, just so we don't always think it has to be a, let's use different letters. If we have a number b, and we add its opposite, then we get 0. And this first one is additive inverse. Additive identity. The second one is additive inverse. And then multiplicative inverse, we'll get to in a second. Multiplicative identity says that anything times 1 is itself. And then multiplicative inverse says that if you multiply anything by its reciprocal, it's an upside down version of itself. So d over e times e over d, we get 1. Okay. So those are our identities and inverses. Distributive property. So a distributive property, if we have some number and then we have a couple others inside, distributive property tells us that we multiply this times everything that's on the inside. So if we get 5 times 2 is 10. Bring down our sign. Then 5 times 3 is 15. And then 10 plus 15 is 25. Now, since 2 and 3 are both units, since they're both like terms, we could combine them before doing the distribution. And 2 plus 3 would be 5. And now we can distribute, still multiplication, 5 times 5 gives us 25. So in this case, either way, well, in any case, either way you do it, you're going to wind up with the same answer, so you can do it correctly. But because we were able to combine the like terms here, we could do it this way. Now, if you have something instead, some number a, and you have b plus c on the inside of your parentheses, then you're going to wind up with, we need to multiply the a times the b, so that's going to be ab, bring our sign, and then A times C, which would be AC. Okay, because these are not like terms, we cannot combine them before we distribute. And it works the same way for multiplication. And here I'll do a mixed set, so I'll do, let's say, 5 times B plus B. So I could distribute first. I could get 5 times B will be 5B. Bring down my plus sign, and 5 times B again will give us another 5B. And then 5B plus 5B would give us 10B. Or, since these are now like terms, we can combine them first. We'll get 5 times 2B's, and that'll give us 10B's. And for this example, I'll go ahead and illustrate it with a visual as well. This is the same as saying 5 groups of 2B's. This is saying 5 groups of 2 plus 3. So if we've got 2B, 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 and 2B, this is 5 groups of 2B's. That means we've got 10 B's. 2, 4, 6, 8, 10 B's. Okay, so that's all the distributive property is doing, is saying this many groups of this stuff. A groups of B plus C. 5 groups of 2 plus 3. Okay. And then order of operations. We actually have pretty extensive practice on this and on Khan Academy, so I'm not going to go in detail on this with this video. But just remember that it is parentheses first, and then exponents, and then multiplication and division from left to right, and addition and subtraction from left to right. So if we have something like 5 plus 3 parentheses 2 plus 1 squared times 3. Our first step was parentheses. So not exponents, but parentheses. So we actually have something to do here in the parentheses. So everything else is going to stay the same. So it would be 5 plus 3, and we work out our parentheses. 2 plus 1 will be 3 squared times 3. And now we can do our exponents. So everything else stays the same except for the exponent part. So 3 squared, that's going to be 3 times 3, which will be 9. The exponent tells you how many times to multiply the base together. So 3 plus 3 is the same as 2 times 3, which is 6. But 3 times 3, this is 3 squared. And that equals 9. Okay. And then times 3. And now we do our multiplication and division. We do it from left to right. So this is 3 groups of 9s. This is 3 times 9. So we get plus 27. And then times 3. Now we have another multiplication step, so we need to do that before the addition. So we get 5 plus 27 times 3 is going to be 81. And now we can finally add our 5, and we get 86. So make sure to do everything in your parentheses first, but even in the parentheses, you need to follow the order of operations. So if you have parentheses 5 plus 3, parentheses 2 times 3 plus 1, okay, and then times 3, you've got some parentheses in your parentheses. So within this group of parentheses, we need to do this group first. And in this group, we need to do our multiplication first, and then our addition. And then in the larger group, we would do our multiplication by 3 and by 3, and then we would add our 5. Okay. And I believe that covers everything from our first week. Just to clear this out real quick. Keep scrolling by accident. Oh, there was one other thing. Multiplying fractions. If we have something like 4 over 9 times 9 over 4, I noticed a lot of people trying to do this. Butterfly method, cross multiplying. Okay, this is incorrect. It is a shortcut that many people don't understand why it works, and so they don't use it properly for when you have a proportion. Okay, it works when you have a proportion, when you've got this equal sign in the middle. And the reasons why it worked we'll go into at a later time. But basically it's almost never needed, and it's used as kind of a shortcut that I actually do not encourage unless we know how to use it effectively. Okay? But multiplying fractions, you just multiply across the top and across the bottom. So this is the same as 4 times 9 over 9 times 4. And you could either simplify, so 9 divided by 9 is going to be 1, 4 divided by 4 is going to be 1, or you can actually multiply it out, so 4 times 9, that's going to give us 36, over 9 times 4 is 36, and anything divided by itself, except for 0, is 1. 36 will go into 36 one time. Alright, that's going to wrap up this video. If you need additional support, make sure to come to tutoring and or watch our Khan Academy videos and practices, and have a great day.